Welcome to Part 4 of the LEED Green Associate Test Prep video series. In this video, we'll cover sustainable sites and energy and atmosphere. Let's start with sustainable sites. The sustainable sites category focuses on restoring project site elements, integrating the site with local and regional ecosystems, and preserving the biodiversity on which natural systems rely. The credits related to sustainable sites are in the areas of site assessment, site development, rainwater management, heat island effect, and light pollution. These are the specific credits for the BD&C, Building Design and Construction. There is one prerequisite, and you can earn up to 10 points from 6 credits. And we'll talk about each one of these. We'll be describing site design that will minimize evapotranspiration and evaporation, manage pests, and reduce impervious areas and light trespass. You should know the strategies well that can affect each one of these. All BD&C rating systems have the prereq addressing construction activity pollution prevention. The primary purpose is to manage erosion and pollution in order to address waterway sedimentation. It prevents the loss of soil during construction from wind and rain, prevents sedimentation of sewers and streams, and prevents air pollution from construction dust and particles. Some of the BD&C rating systems have additional prereqs. For example, the rating systems for health facilities and schools require an environmental assessment, and operations and maintenance instead has a prereq to develop a site management policy. It's important to know some of the strategies that can be used to meet the prereq or the credit requirements. Some of the strategies that can be used for erosion and pollution control include using mulch, berms, straw bales, silt fences, and erosion control blankets. The credit for site assessment influences over a dozen other LEED credit areas, some directly and others indirectly. Site planning should take a whole system approach that examines several aspects, such as the topography, looking for unique features and slope stability risks. The hydrology, looking at flood hazard areas, wetlands, lakes, streams, shorelines, rainwater collection and reuse opportunities, and the capacity of the site to absorb water. Climate, looking at solar exposure, sun angles, and temperatures throughout the year, and at wind, monthly rainfall, or snowfall. Vegetation, examining the plants, trees, threatened or endangered species, invasive plants, and undeveloped areas, also known as greenfield areas. Human use, looking at views, available transportation, properties surrounding the location, and construction materials that can be recycled or reused. And finally, human health effects, looking at opportunities for physical exercise nearby and nearby threats, such as sources of air pollution or vulnerable populations. You can get a 1 to 2 credits for protecting or restoring habitat. The first step is to revegetate all disturbed or compacted soils in the development footprint. The requirements are to preserve and protect 40% of the greenfield area on the site, if such areas exist, from all development and construction activity. And you'll want to restore a portion of the site, including the building footprint, identified as previously disturbed, if such areas exist. This includes restoring disturbed areas in areas that will later serve as the final habitat area, and planting vegetation that is native and adapted. Vegetated roof surfaces may be included in the habitat area calculations if the plants are native or adapted and provide habitat. You can get a credit for ensuring that you have sufficient open space. The purpose of the credit is to minimize hardscape, which helps with water infiltration and provides opportunities for residents or employees to connect with nature. The requirement is to provide outdoor space greater than or equal to 30% of the total site area, including the building footprint. A minimum of 25% of that outdoor space must be vegetated, and turf grass does not count as vegetation, or have overhead vegetated canopy. Some of the strategies that can be used to provide open space include pedestrian paving, or turf for social activities, a recreation area for physical activities, a garden, a community garden, and preserved or created habitat. Be sure you know what constitutes an open space and who has access to it. You can get up to 3 credits for rainwater management. The purpose of the credit is to control runoff and improve water quality for restoring the natural hydrology of the site, managing both quantity and quality. Quantity control is used to slow the rate of runoff, maintain the natural flow, and promote infiltration. To do that, you need to control the rainwater. Quality control uses best management practices, or BMPs, to reduce the amount of pollutants that enter water and improve water quality. Non-point source pollution is pollution from multiple sources that's impossible to identify. Low-impact development manages rainwater by mimicking nature. You can collect and reuse the water for non-potable use, and to replicate the natural balance, you can use low-impact development, or LID, and green infrastructure. You can minimize impervious areas. You can install dry ponds, rain gardens, bioswales to slow runoff, and incorporate rainwater management into site design. You can increase vegetated roofs and porous pavements and grid pavers. You can harvest rainwater by adding a rainwater cistern to capture water from roof downspouts. And from a non-structural standpoint, you can use rain gardens, pervious pavement, and vegetated swales. Redirect the rainwater by installing swales and ponds to hold the water. In the site design process, synergize the features by doing multiple functions, like when planters collect rainwater, and mulch holds moisture, and build soils. Low-impact development is very important to know and understand. Low-impact development uses or mimics natural processes that result in infiltration, evapotranspiration, or use of stormwater in order to protect the water quality and associated aquatic habitat. Some strategies that you can use include using native landscaping, bioswales, bioretention cells, level spreaders, pervious paving, and rain gardens. This is a very good slide to stop and examine. Green roofs are great to add when properly designed. They manage stormwater, reduce the heat island effect, provide habitat, filter air pollution to clean the air and water, slow the increase of CO2, treat nitrogen pollution in rain, negate acid rain, and reduce energy needs like air conditioning. LEED defines the heat island effect as temperatures that are 10 degrees higher than the surrounding urban area. This heat contributes to smog and wildlife declines and human comfort. It's especially concentrated in cities because of the density of structures and exacerbated by dark surfaces that retain heat. Black roofs can contribute to the heat island effect, but they're sometimes used on commercial buildings because they actually absorb more heat and can keep buildings warmer in colder climates, which can lower heating costs and are less likely to accumulate snow and ice, which can make them safer and easier to clean in the winter. Here are a number of important terms to know. Solar reflectance is a measurement of how much solar radiation a surface or a material reflects from its surface back into the atmosphere. Solar reflectance is measured in decimals on a scale of 0 to 1, where 0 would be considered the truest black and 1 would be considered the truest white. Albedo. The albedo effect is the result of solar reflectance and is the ability of a roof to reflect sunlight away from a building, which can help reduce energy costs and improve a building's energy efficiency. It can also help to mitigate the urban heat island effect and reduce the need for cooling energy. Emissivity is a measure of how efficiently and quickly a surface releases or emits absorbed heat and returns to its normal temperature. Emissivity is determined on a decimal scale from 0 to 1, where 1 represents the most efficiently emissive material possible. In essence, the higher the number, the better it will be at cooling itself. The Solar Reflectance Index, or SRI, combines reflectivity, or albedo, and emissivity. It is a measure of a surface's ability to reflect the sun's solar energy and emit heat. SRI is measured on a scale from 0 to 100. An SRI value closer to 0 indicates a darker or black surface, and a value closer to 100 indicates a brighter or white surface. The Lawrence Berkeley National Laboratory created a downloadable SRI calculator where you can put the solar reflectance and emissivity values, and it will calculate it for you. Now be sure you know the difference between solar reflectance, or SR, and the Solar Reflectance Index, or SRI. Solar reflectance is used for non-roof measures, and the SRI is used for roofs. We'll talk about that next. There are non-roof and roof strategies you can use to reduce the heat island effect. Non-roof measures include using shade trees or plants that provide shade over paving areas, including playgrounds, on the site within 10 years of planting. Also can have vegetated planters, structures covered by energy generation systems, such as solar thermal collectors, photovoltaics, and wind turbines. Architectural devices or structures with a solar reflectance, or SR, value of at least 0.28. Vegetated structures, or paving materials with a solar reflectance, or SR, value of at least 0.28. And open grid pavement systems that are at least 50% pervious. Roof strategies include using a cool roof or a high reflectance roof. You need to use roofing materials that have a specific minimum SRI, which differs whether it's a low-sloped roof or a steep-sloped roof. A low-sloped roof must have an initial SRI of 82, with a 3-year aged SRI of 64. A steep-sloped roof must have an initial SRI of 39, and with a 3-year aged SRI of 32. Or you can use a vegetated roof, or use renewable energy systems such as photovoltaic, solar thermal, or wind turbines. Or option 2 is to have parking under cover. You can place a minimum of 75% of parking spaces under cover. Any roof used to shade or cover parking must have a 3-year aged SRI of at least 32, or be a vegetated roof, or be covered by energy generation systems such as solar thermal collectors, photovoltaics, and wind turbines. You need to know the differences between the SRI and the SR values. You need to know the values. And you need to know the difference between non-roof and roof strategies. You can get a point for reducing light pollution. light in the evening is important for safety and work and can add to the beauty of a building. However, light can have a detrimental effect on wildlife and can reduce the beauty and visibility of the stars and can increase the glare that can affect neighbors. To get the credit, you need to meet the uplight, glare, and light trespass requirements using either the bug method, backlight, uplight, glare, or the calculation method. Strategies to minimize light pollution include, for indoor, you can use indirect interior lighting, you can shut off non-emergency lighting, and you can shield lights to keep them focused on their target area. For exterior lighting, you can design with a computer model and only light for comfort and safety, reducing non-essential lighting, especially on the facade, and prevent uplighting. The bug method establishes the maximum lumens for each region. Backlight, or B, is the light that is directed behind the fixture. Uplight, or U, is the light that is directed upwards above the light fixture's horizontal plane, and glare, or G, is the light that is emitted from the fixture at high angles. Be sure you know the bug method. In sum, site design can contribute significantly to the sustainability of your project. In this section of the video, we've looked at construction activity, open space, water quality and quantity, heat island effect, and light pollution. Now let's move on to the very important category of energy and atmosphere. The goals and intents of the EA category are to reduce energy use, design for energy efficiency, and promote renewable energy use. One of the important aspects of LEED rating systems is the use of various other standards that set the minimums and best practices that should be used to meet prerequisite and credit requirements. This is very practical on LEED's part because it eliminates duplication and reduces the number of revisions that LEED would need to make in order to stay aligned with other standards that are widely used. You will need to know the purpose of certain standards. In the energy arena, a lot of the requirements for LEED prereqs and credits are found in ASHRAE standards. ASHRAE overall looks at heating, ventilation, air conditioning, and refrigeration. Most important one to know in the energy category is ASHRAE 90.1, which sets energy and lighting performance standards for commercial buildings. Some others to know are ASHRAE 50%, and ASHRAE Advanced Energy Design Guides, which delineate a baseline for energy performance. ASHRAE 0, which covers mechanical, electrical, plumbing, and renewable energy systems. ASHRAE 1.1, which covers HVAC and R systems, i.e. Energy, water, IEQ, and durability. And the use of the U.S. Department Energy Commercial Buildings Energy Consumption Survey, or CBEX, which is an electrical baseline for on-site renewable energy and green power, and the National Institute of Building Sciences, NIBS, Guideline 3, exterior enclosure technical requirements. And finally, the International Performance Measurement and Verification Protocol, IPMVP Volume 3. So be sure you know the ASHRAE standards that we specifically highlight. Make sure you know those very well. In this case, it's primarily ASHRAE 90.1. These are the prerequisites and credits for the energy and atmosphere category. There are 4 prerequisites and up to 33 points in 7 credit areas that you can earn, which reflects the emphasis that LEED puts on climate change and the impact that energy has. We'll cover each of these, but you can see the summary of the prereqs and credits here. The prereqs include fundamental commissioning, minimum energy performance, building level metering, and fundamental refrigerant management. The 7 credits include enhanced commissioning, optimizing energy performance, advanced energy metering, demand response, renewable energy production, enhanced refrigerant management, and green power. Prereq 1 is fundamental commissioning. Commissioning is a systematic process of assuring that a building performs in accordance with the design intent and the owner's operational needs. In other words, commissioning is making sure that the building runs right. It was inspired by the Navy practice of a shakedown cruise. There are several definitions that you should know. The Owner's Project Requirements, or OPR, identifies what the owner thinks is important to the success of the project. The Basis of Design, or BOD, is the info needed to complete the owner's requirements. This includes system descriptions, indoor environmental quality criteria, design assumptions, and a list of the codes and standards needed for the project. Commissioning, or CX, is the process of checking all the building systems are planned, designed, installed, tested, operated, and maintained to meet the owner's requirements. The CXA is the commissioning authority, who is the person who leads the commissioning process. Well, who can this be? Well, the CXA can be an employee of the architecture or engineering firm, a subcontractor to them, or to the general contractor or construction manager, or an employee of the owner or an independent consultant contracted to the owners. And finally, the CX plan is something that we will talk about next. You need to know what should be in the plan. The commissioning plan establishes the commissioning process guidelines for the project and the commissioning team's level of effort. It identifies the required CX activities to ensure that the OPR and the BOD are met. The CX plan also includes a commissioning schedule from design to occupancy. Most activities of fundamental building system commissioning happen during the equipment startup and project closeout, and they apply to mechanical, electrical, plumbing, and renewable energy systems. The commissioning plan is started during the design phase of the building project and is written prior to receiving the permits for the project. The commissioning plan includes some general project information, the commissioning goals, the systems to be commissioned, and plans to test the systems and components, which should have an explanation of the original design intent, the equipment and systems to be tested, including the extent of the tests, the functions to be tested, the conditions under which the test will be performed, the measurable criteria for acceptable performance, the commissioning team information, including their roles, and the commissioning process activities, schedules, and responsibilities. The commissioning process is a valuable one. You start by developing and implementing a commissioning plan. Then you will incorporate commissioning requirements into the construction documents, develop construction checklists, and develop system test procedures. As testing is done, you'll verify system test execution and maintain an issues and benefits log throughout the commissioning process. The commissioning report is completed by the commissioning authority after the construction is complete. It has a summary of the testing results, confirmation of adherence to the OPR and BOD, any deficiencies, and corrective action. The second prerequisite is minimum energy performance. The intent of this prereq is to establish the minimum level of energy efficiency for the proposed building and systems so as to reduce the environmental and economic impacts associated with excessive energy use. The improvement has been ratcheted up over time. Projects that registered on or after April of 2016 must demonstrate an 18% improvement for new buildings, or a 14% improvement for major renovations to existing buildings, over the baseline average of buildings in the system. This performance is calculated using the Building Performance Rating method in ASHRAE 90, using a computer simulation model for the project. One last interesting twist to the minimum energy performance prerequisite that is unique to homes. It uses ENERGY STAR and HERS modeling to meet the prerequisite. You will need to complete all mandatory measures of ENERGY STAR for Homes version 3 and achieve a HERS index rating that meets or exceeds the ENERGY STAR HERS index target, which is the highest HERS index value that a home can achieve and qualify under the performance path of the program. The performance path provides flexibility to select a custom combination of measures through energy modeling that achieves the required ENERGY STAR HERS index target. The third prereq is building level energy metering. The intent of this prereq is to use energy metering to identify opportunities for additional energy savings by tracking building level energy use. Projects need to install new or use existing building level energy meters, or some meters that can be combined to provide total building energy consumption, like electricity, natural gas, chilled water, steam, fuel oil, propane, biomass, etc. Utility-owned meters can be used. You will need to commit to sharing energy use with USGBC for a 5-year period. Energy consumption must be tracked at least in 1-month intervals. The tracking and sharing periods of time are most important. It's important to know the different types of energy. Site energy is the energy usage you see in bills. Primary energy is the energy generated on site, whereas secondary energy is the energy that is purchased. Source energy includes line loss. Now, non-process or regulated energy includes the built-in building components. Some examples are interior and exterior lighting, such as parking, garage, security, landscape, and architecture. HVAC, heating, cooling, fans, and pumps. And hot water heating, toilet exhaust, and parking garage ventilation. So that's non-process or regulated energy. Process energy usually comes from equipment that is plugged into a wall outlet. It has a plug load. Examples of process energy include computers, office equipment, kitchen stoves, kitchen refrigerators, washers and dryers, food prep equipment, medical equipment lighting, elevators and escalators. Yes, these don't have regular plugs, but they are considered process energy for LEED. Unregulated or process load is load from process energy. Plug loads is energy used by wall outlets. Energy use intensity is a measure of how much energy a building uses per square foot, typically expressed in BTUs per square foot per year. It's calculated by dividing the total energy consumed by a building in a year by its gross floor area. EUI is a key indicator of a building's energy performance, similar to how many miles per gallon is used to measure a car's performance. The ENERGY STAR program recommends using source EUI, which takes into account all transmission, delivery, and production losses for the energy used by a building. Prereq 4 is fundamental refrigerant management. This is a very important slide with a lot of important details. The intent of this prereq is to reduce ozone depletion and global warming potential, and support early compliance with the Montreal Protocol, which focuses on ozone depletion while minimizing direct contributions to climate change. The Montreal Protocol is the treaty that phased out CFCs by 2010, HCFCs by 2030. Prereq 4's requirement is not to use chlorofluorocarbons, or CFCs, or hydrochlorofluorocarbons, HCFC-based refrigerants in new heating, ventilating, air conditioning, and refrigeration systems. When reusing equipment, you'll need to complete a phase-out conversion before project completion. Now let's go through this chart. The chart identifies each category of refrigerants, along with the ozone depletion potential, or ODP, the global warming potential, or GWP, and the permitted uses in LEED. The first is CFCs, which are banned by this prereq. CFCs are a refrigerant with the most impact on ozone layer. It's very, very bad. It has a high ozone depletion potential and a high global warming potential. Next is hydrofluorocarbons, or HCFCs, a type of refrigerant which is less harmful than CFCs with a lower ODP and a medium GWP. While HCFCs aren't perfect, they're much better than CFCs when it comes to the ozone and global warming incidental. However, they are still bad for global warming potential. Then we have HFCs. HFCs have a negligible ODP, making them a suitable choice for reducing ozone damage. However, many HFCs have a high GWP. This led to an amendment of the Montreal Protocol called the Kigali Amendment to include a phasing out of HFCs because of their global warming potential. It may be used for the time being, and you would still meet the prerequisite requirement, but if you want to go for the enhanced refrigerant management credit, you'll need to calculate your refrigerant impact. More on that later. Next is halon, which is used as a fire extinguisher, and it is banned by this prerequisite. Halons have a high ODP, up to 10 times greater than CFCs. Halons also have a very high GWP. For all replacements, there's considerable savings in terms of ozone depletion. However, for many, there is little benefit in terms of global warming, and in some cases, the global warming effects of a halon replacement greatly exceed the global warming effects of the halon it replaces. There is one replacement, NAFS3, that is acceptable in both ODP and GWP. A good option is to use natural refrigerants. Surprisingly, at least to me, is that CO2, ammonia, and hydrocarbons are on the list of natural refrigerants, as is water. These have no ODP and a low GWP. And finally, from the standpoint of ODP and GWP, the best option is natural ventilation. However, that's not very practical in hot, humid climates like Florida. You can get up to 6 points for pursuing enhanced commissioning. The intent is to continue to test the equipment and operation of a project to make sure it meets the owner's project requirements for energy, water, indoor environmental quality, and durability. There are 2 options, and the first option has 2 paths. Option 1, Path 1, is to verify the training, seasonal testing, and ongoing commissioning. Option 1, Path 2, is to develop a monitoring-based procedure and identify points to be measured and evaluated to assess performance of energy and water-consuming systems. Option 2 is to expand the commissioning process to look at the building's thermal envelope as it relates to energy, air, and water tightness, indoor environmental quality, and durability. The building enclosure commissioning should address training, seasonal testing, and a plan for maintenance, renewal, and revitalization. Know the difference between enhanced and regular commissioning. Now this is a big one. You can get up to 18 points for optimizing energy performance. The intent of the credit is to go beyond the prerequisite standard to reduce environmental and economic harms from energy and greenhouse gas emissions. The requirement is to analyze efficiency measures during the design phase using what-if energy simulation of efficiency opportunities, energy simulations for similar buildings, or prescriptive guides such as the Advanced Energy Design Guide. Option 1 is to demonstrate the percentage improvement on a proposed building using simulation. Total LEED points are determined by summing the points for percentage improvement in energy performance based on cost, plus the percent reduction in greenhouse gas emissions. Option 2 is to implement the recommendations and standards in ASHRAE 50% Advanced Energy Design Guide. And option 3 is to optimize the systems by using the strategies in the prescriptive compliance path in ASHRAE 90. Here are some of the strategies that can be used to increase energy efficiency. The goal is to use less energy for the same work. You can improve building envelope to reduce HVAC by weatherizing the building to reduce leaks and improving insulation. Selecting high-efficiency appliances. Selecting high-performance heating and cooling systems, whether they are HVAC systems that meet and exceed Energy Star, or for larger projects, district heating and cooling systems that deliver heated or chilled fluids to buildings and industrial processes through a network of insulated pipes. The energy is usually generated in a central location and can come from a variety of sources, including renewable energy, waste, and cogeneration, which simultaneously generates electricity and useful heat from a single energy source, like natural gas or biofuels. Reducing lighting power density, the amount of electric power used to illuminate a space, which is measured in watts per unit of area, or for outside, installing efficient street lighting with LEDs. Conducting energy simulations and computer modeling, and monitoring and verifying performance with building automation. And finally, adding high-performance glazing or windows. You can earn 1 point for advanced energy metering. The intent of the credit is to identify opportunities for additional energy savings by tracking building level and system level energy use. The requirement is to install metering for all whole building energy sources in the building and for any energy end uses that are more than 10% of the total consumption. The next credit is grid harmonization using demand response. This credit has the possibility of gaining 2 points. The intent of the credit is to increase participation in demand response technologies and programs that make electricity more affordable and more efficient by shifting your demand to times when the demand is lower, thus reducing the need to build additional power plants. As energy demand increases, we can meet peak demand in 2 ways. On the supply side, we can build more stuff, or on the demand side, we can optimize energy use. Some examples of how we can do this are to consume less, curtail energy use during critical peaks, and shift consumption to times in which there's lower demand, and self-generate. There are 3 cases that can be applied to your project. Case 1 is to participate in an existing demand response program. The second case is to build so that you can participate in a future demand response system. And the third case is to implement load flexibility and management strategies, such as peak load optimization and on-site thermal or electricity storage. Well, what are some of the strategies that will help you reduce energy demand? You can, first of all, size the building no larger than needed. That is the best way to minimize energy and environmental impact. You can use passive strategies. Configure your building to minimize solar gain in the summer and maximize it in the winter. You can also maximize natural lighting and natural heating. Passive strategies can include building orientation, natural ventilation, daylight, shade, solar energy, and thermal masses for heating. You can set energy goals. You can insulate efficiently, and you can monitor consumption by using technology, that is, using building simulation software to understand consumption. You can get up to 5 points for making use of renewable energy systems to offset building energy costs. The intent of the credit is to reduce the environmental and economic harms associated with fossil fuel energy and reduce greenhouse gas emissions by increasing the supply of renewable energy projects both on and off-site. The requirement is to use on-site renewable energy systems or procure renewable energy from off-site sources for all or a portion of the building's energy use. Now you know that non-renewable energy includes coal, nuclear, and natural gas. You can choose one or more strategies for renewable energy procurement. Points achieved in each category may be added for a total of 5 points. Tier 1 is on-site renewable energy generation. Tier 2 is new off-site renewable energy, and Tier 3 is existing off-site renewable energy that is Green Energy certified or captured biomethane. The default contract length for renewable energy procurement is 10 years. Contract lengths for less than 10 years may be prorated. It's important to know which types of energy LEED considers to be green power and which are not. Green power includes solar, wind, wave, biomass, geothermal, hydropower, and methane capture. On-site renewable energy includes PV, solar hot water, and building-mounted wind turbines. Methane capture in the form of biogas that is both captured and used on-site may qualify as a Tier 1 renewable energy resource. Not renewable energy are passive solar, geo-exchange or ground source heat pumps, waste-to-energy plants, treated wood, forestry waste, and natural ventilation. Earlier we mentioned the enhanced refrigerant management or earlier compliance with the Montreal Protocol. The intent of this credit is to support early compliance with the Montreal Protocol while minimizing the direct contribution to climate change. Option 1 is to use no refrigerants or low-impact refrigerants, whether naturally occurring or synthetic, that have an ozone depletion potential of 0 and a global warming potential of less than 50. You can get 1 point for that. Option 2 is to calculate your refrigerant impact to ensure that it is less than 100 and implement a refrigerant management plan that addresses leak detection, system retrofit, and an end-of-life disposal for all HVAC and R systems. You will calculate the life cycle global warming potential plus the ozone depletion potential times 105 and ensure that that is less than 100. You can get 1 point for implementing that option. In summary, this video covered sustainable sites and energy and atmosphere. The next video will cover water efficiency and materials and resources. See you then.